Hello everyone. Today we will study another probability distribution called exponential distribution. First of all, let me introduce what it is. Under a fixed condition, events occur continuously. Under a fixed condition, events occur continuously. And the occurrence of the events are independent. That means the occurrence of one event won't affect the occurrence of another event. They are all independent. Suppose the average waiting time for occurrence of the events Suppose an average waiting time for the occurrence of the events is known. Denoted by theta. Here, theta represents the average waiting time for the occurrence of events. Let the continuous random variable let the continuous random variable x represent the actual waiting time for the occurrence of events. Then we say x has an exponential distribution. Next, we'll try to find its probability density function. Next, we try to find its probability density function, the PDF. We try to find its PDF f of x using Poisson distribution. Here in the PDF f of x, this x represents a time period. In the PDF f of x, this x represents a time period. So within the time period x, this x represents a time period. Within the time period x, let lambda represent the average number of occurrence of events. Then, how can we compute lambda? How can we compute lambda here? Lambda represents average number of occurrence of events. Theta represents average waiting time of occurrence of events. X is a time period. If I take the time period x divided by the average number of occurrence of events, I get an average waiting time. If I take the time period divided by the average number of occurrence of events, I get an average waiting time of occurrence of an event. For example, if the time period is 100 minutes, and within this time period, the event occurs 4 times. If the time period x is 100 minutes, and within this time period, the event occurs 4 times, then the average waiting time for occurrence of an event, I take 100 divided by 4 is 25. So within the time period 100 minutes, if the event occurs 4 times, then the average waiting time is 25 minutes. That's what this formula means. X is the time period. Lambda is the average number of occurrence of the events. If I divide, I get theta. Theta represents the average waiting time for occurrence of the event. So that's this formula. X divided by lambda equal to theta. Then, if I solve this equation for lambda, lambda can be found using x divided by theta. Taking the time period divided by the average waiting time, we can find the average number of occurrence of an event. So lambda can be found using x over theta. Next, I will define another random variable called y. Then the discrete random variable y represent the actual number of occurrence of the events. then y represents the actual number of occurrence of events. Since lambda is known, y has a Poisson distribution. Since lambda is known, y has a Poisson distribution. So let here y represents actual number of occurrence of events in the same time period. In the same time period x. Since lambda is known, y has a Poisson distribution. Y has a Poisson distribution with lambda equal to x over theta. Then we can try to find its probability function. Let me use g of y. Let me use g of y to represent its probability function. Let me use g of y to represent its probability function because we use f of x already. Let me use some different letters. Let me use g of y to represent its probability function. How do we write g of y? How do we write g of y? In general, the formula for Poisson distribution is e raised to negative x, e raised to negative lambda, times lambda to the power of x over s factorial. That's the formula for Poisson distribution in general. But here, variable is y. The variable is y. In function g, the variable is y. So I replace each x with y. Then I can plug in theta. I can plug in lambda. Lambda is x over theta. Plug in lambda. I get e raised to negative x over theta times x over theta to the power of y over y factorial. That's the probability function of y. That's the probability function of y. And the support of y. What's the support of y? Since y has a Poisson distribution, support of y is all integers from 0 to infinity. Since y has a Poisson distribution, support of y is for all integers from 0 to infinity. Next, we solve from the PDF f of x based on g of y. Lowercase x represents a time period. Lowercase x represents a time period. Capital X represents the actual waiting time for the occurrence of an event. Capital X represents the actual waiting time for the occurrence of an event. Suppose capital X is less or equal to x. What does it mean? Capital X is the actual waiting time for the occurrence of an event. If capital X is here, that means no events occurs here. If capital X is here, that means no events occurs until x. No events occurs until x. And then after x, events occur. No event occurs from 0 to capital X. After x, event occurs. So, if capital X is less than x, that means within the time period from 0 to x, event occurs at least once. That means within the time period from 0 to x, event occurs at least once. And we know y represents the actual number of occurrence of events. Y represents the actual number of occurrence of events. So if x is less or equal to x, y must be greater than or equal to 1. Event must occur at least one time. Must occur at least once. If capital X is less than x, That means an event occurs at least once in this time period, which means y is greater or equal to 1. So if the actual waiting time for the occurrence of an event is less than x, lowercase x, then events occurs at least once. Events occur at least once. Within the time period x. So probability that x less or equal to x, probability that x less or equal to x is the same as probability that y greater or equal to 1. That means within the time period x, event occurs at least once. How can we find y greater or equal to 1? How can we find probability that y greater or equal to 1? We know that support of y is all integers from 0 to infinity. But y greater or equal to 1, y could be 1, 2, 3, 4, 5. There are too many terms. We can try to find its complement. That's a little easier. So for the complement, we can use 1 minus g of 0. One minus probability that y equal to 0, which is the same as 1 minus g of 0. Now, how do we find g of 0? For g of 0, we plug in 0 into function g. For g of 0, plug in 0 into function g. If I plug in 0 into function g, I have e to the power of negative x over theta times x over theta to the power 0, plug in 0 for each y, not for x. Variable in function g is y, plug in 0 for each y, over 0 factorial. If I simplify, I have 0 factorial is 1. 0 factorial is 1. Every number raised to power 0 is 1. Every number raised to power 0 is 1. So I have e raised to negative x over theta. The denominator 0 factorial is 1. So it disappears. Every number raised to power 0 is 1. So what's left is e raised to negative x over theta. So we have p of x less or equal to x that equal to 1 minus e raised to negative x over theta. Now, what does this mean? What does probability that x less or equal to x means? This function f is a PDF. Function f is the PDF. Probability that x less or equal to x, that means for PDF, we use area under the curve represent probabilities. For PDF, we use area under the curve represent probabilities. So probability that x less or equal to x. From last class, we know that probability that x less or equal to x, let's integral from net infinity to x, f of x dx. In general, to avoid confusion, write f of t dt. In general, to avoid confusion, instead of x here, we write f of t dt. To avoid confusion, we write f of t dt. So, probability that x less or equal to x is integral from net infinity to x, f of t dt. we can write x, but to avoid confusion, let me write f of t dt here. That equal to 1 minus e raised to negative x over theta. So probability that x less equal to x is the integral from negative infinity to x f of t dt. Next, we try to find f of x. If I take derivative on both sides, what do we get? If I take derivative on both sides, what do we get? If I take derivative on both sides, what do we get? On both sides, take derivative with respect to x, what do we get? On the left side, by fundamental theorem of calculus, fundamental theorem of calculus says derivative of integral from a to x f of t dt equal to f of x. That's fundamental theorem of calculus. I plug in x for t. That's fundamental theorem of calculus, which means integral derivative cancels integral, we get f of x. Which means derivative cancels integral, I get f of x. That's fundamental theorem of calculus. So on the left side, apply fundamental theorem of calculus. On left side, apply fundamental theorem of calculus. I get f of x. On the right side, take derivative. Derivative of 1 is 0. Then take derivative for this exponential function. I have e negative x over theta times derivative of an exponent, which is negative 1 over theta. If I simplify, I have f of x equal to 1 over theta e raised to negative x over theta. If I simplify, that's what we get here. Since this x represents time period, since this x represents a time period, x cannot be negative. A time period cannot be negative. So s must be greater than or equal to 0. S cannot be negative. This x is time period, it cannot be negative. So s must be greater than or equal to 0. So f of x equal to 1 over x e raised to negative x over theta if s is greater than or equal to 0, and 0 otherwise. This is the PDF of x. This is the probability density function of x. And here x has an exponential distribution. X has an exponential distribution. What's the support of x? What's the support of x? Support of x is all x greater than 0. X represents a time period. Time period cannot be negative. So it could be any positive number from 0 to infinity. That's support of x. The notation. Notation for exponential distribution, write it like this. We write x has exponential distribution the only perimeter is theta here. The only perimeter here is theta. Or we can write it as ESP. It's a shortcut, we can write it as ESP of theta. The perimeter here is theta. Theta represents the average waiting time for occurrence of an event. Theta represents the average waiting time for occurrence of an event. So keep it in mind. Theta represents the average waiting time for the occurrence of an event. Capital X represents the actual waiting time for the occurrence of an event. Theta represents the average waiting time for the occurrence of an event. Capital X represents the actual waiting time for the occurrence of an event. Next, let's look at an example here. Let X have exponential distribution with theta equal to 3. Find each of the following probabilities. Part A, probability that X is greater or equal to 2. Part B, probability that X is less or equal to 6. Part C, probability that X is between 3 and 4. So let's first of all set out the problem first. First step, let's write down the probability density function, the PDF first. For exponential distribution, the PDF is 1 over theta e raised to x over theta if x is greater than or equal to 0 and 0 otherwise. That's the PDF. And then here we know that the number in the parentheses is theta. So theta equal to 3. We plug in 3 for each theta. Plug in 3 for each theta. That's the PDF. What's the support? For exponential distribution, support is always from 0 to infinity, including 0. For exponential distribution, support is always from 0 to infinity, including 0. So that's the setup. Based on the setup here, answer the question. Part A, what's the probability that x is greater than or equal to 2? Here, since x is a continuous random variable, we take integrals. Support is from 0 to infinity. If s is greater than 2, we take integral from 2 to infinity. Support is from 0 to infinity. Since s is greater than 2, we take integral from 2 to infinity. F of x dx. When s is from 2 to infinity, f of x is 1 over 3 e raised to negative x over 3. So plugging here, we have 1 over 3 e raised to negative x over 3 dx. Then take antiderivative. How do we take antiderivative for exponential distribution? When we take antiderivative for exponential distribution, we can make u substitution. The u equal to negative x over theta, then du is negative 1 over theta dx, which means negative theta du equal to dx. If we plug in, we have 1 over theta times e raised to power u times negative theta du. 1 over theta and negative theta can cancel. We have negative integral e to the power u du. Cancel theta. We have negative e to the power u du. And antiderivative of e to the power u stays the same. It's negative e to the power u, and u is negative 1 over theta, negative x over theta. Plug in. So this is the antiderivative of exponential distribution. So when we take antiderivative, 1 over theta disappear, add negative sign to the front. When we take antiderivative, 1 over theta disappear, add negative sign to the front. Keep it in mind. When we take antiderivative, 1 over theta disappear, add negative sign to the front. So here, when we take antiderivative, 1 over 3 disappear, add negative sign in the front. Evaluate from 2 to infinity. If I plug in infinity, e raised to negative infinity is 0. If I plug in 2, I get e raised to negative 2 over 3. Double negative is positive, so the answer is e raised to negative 2 over 3. E raised to negative 2 over 3. Part B. What's the probability that x is less than or equal to 6? What's the probability that x is less than or equal to 6? Suppose from 0 to infinity. If x is less than or equal to 6, that's the integral from 0 to 6, f of x dx. Suppose from 0 to infinity. If x is less than or equal to 6, take integral from 0 to 6. And then when s is between 0 and 6, I take f of x equal to 1 over 3 e raised to negative x over 3. Plugging integral from 0 to 6, 1 over 3 e raised to x over 3 dx. Then take antiderivative. When I take antiderivative, 1 over theta disappear, add negative sign to the front. Negative e raised to negative x over 3. Evaluate from 0 to 6. If we plug in 6 over 3 is 2. You get e raised to negative 2. If I plug in 0, e raised to power 0 is 1. So the final answer is 1 minus e raised to negative 2. The final answer, 1 minus e raised to negative 2. Part C. What's the probability that s is between 3 and 4? What's the probability that s is between 3 and 4? Suppose from 0 to infinity. So if s is between 3 and 4, I take integral from 3 to 4. Take integral from 3 to 4. F of x dx. Then for s is between 3 and 4, when s is between 3 and 4, s is greater than 0. So I use 1 over 3 e raised to negative x over 3. Plugging, I get 1 over 3 e raised to negative x over 3 dx. Then take antiderivative. When I take antiderivative for exponential distribution, remove 1 over theta, add negative sign. I get negative e raised to negative x over 3. Evaluate from 3 to 4. When I plug in 4, I get negative e raised to negative 4 over 3. When I plug in 3, I get negative e raised to negative 1. So the final answer, e raised to negative 1 minus e raised to negative 4 over 3. That's the final answer. Next example, the average lifetime of a certain type of electronic tubes is known to be 400 hours. Part A, what's the probability that a tube will last more than 800 hours? Part B, what's the probability that a tube will fail within the first 400 hours? First step, decide what type of probability distribution it is. First step, decide what type of probability distribution it is. The problem says the average lifetime of a certain type of electronic tubes is known to be 500 hours. That means On average, we wait 500 hours for the failure of a tube. On average, we wait 500 hours for the failure of a tube. If we know the average waiting time for occurrence of an event, we can use exponential distribution. So let x represent the actual lifetime of a tube. The x represents the actual lifetime of a tube. Then x has exponential distribution. X has exponential distribution. Theta is the average waiting time. Theta is the average waiting time for the occurrence of an event. We know that on average, we wait 500 hours for the failure of a tube. On average, we wait 500 hours for the occurrence of the failure of a tube. So theta is 500. Then write down the probability function. Write down the probability function and support. For exponential distribution, the formula is 1 over theta e raised to x over theta if s is greater or equal to 0 and 0 otherwise. Plug in theta. Theta is 500. Plug in 500 for each theta. We have 1 over 500 e raised to negative x over 500. That's the probability density function. That's the PDF. This is the PDF. And what's the support? For exponential distribution, support is always from 0 to infinity, including 0. For exponential distribution, support is always from 0 to infinity, including 0. Now, based on this, answer the question. Based on this information, answer the question. Part A. What's the probability that a tube will last more than 800 hours? That means, what's the probability that the lifetime is more than 800? Part A asks, what's the probability that a tube will last more than 800 hours? That means, what's the probability that the lifetime of the tube is more than 800? Since x is a continuous random variable, we take an integral for the probabilities. Since x is a continuous random variable, we take integral for the probabilities. Support is from 0 to infinity. If x is greater than 800, take integral from 800 to infinity. And when x is between 800 and infinity, when x is more than 800, we use f of x equal to 1 over 500 e raised to negative x over 500. Plug in here. 1 over 500 e raised to negative x over 500 dx. Then we take the antiderivative. We know that for exponential distribution, when I take antiderivative, 1 over theta disappear. It becomes negative e raised to negative x over 500. Evaluate from 800 to infinity. If I plug in infinity, e raised to negative infinity is 0. If I plug in 800, I get e raised to negative 800 over 500. Double negative is positive, which is e raised to negative a over 5. That's the probability that the tube will last more than 800 hours. That's the probability that the tube will last more than 800 hours. Part B. What's the probability that a tube will fail within the first 400 hours? What's the probability that the tube will fail within the first 400 hours? That's the probability that the lifetime of a tube is less than 400 hours. That's the probability that the lifetime of a tube is less than 400 hours. Since the support is from 0 to infinity, if x is less than 400, take integral from 0 to 400. Take integral from 0 to 400. F of x dx. And we know that when x is between 0 and 400, x is greater than 0. We use f of x equal to 1 over 500 times e raised to negative x over 500. Plug in 1 over 500 times e raised to negative x over 500 dx. Then we take antiderivative. 1 over theta disappear. Add negative sign. E raised to negative x over 500. Evaluate from 0 to 400. If I plug in 400, I get negative e raised to negative 400 over 500. If I plug in 0, e raised to power 0 is 1. So I have 1 minus e raised to negative 4 over 5. That's the probability that a tube will fail within the first 400 hours. Next example, in a city, the past weather reports indicate that there's a huge snowstorm every 8 years. Assume last snowstorm occurred in the year 2014. Part A, what's the probability that there is a snowstorm this year? Part B, what's the probability that there won't be a snowstorm before the year 2024? First step, let's decide what type of probability distribution it is. In the problem, we know that on average, there's a snowstorm every 8 years. That means on average, we wait 8 years for the occurrence of a snowstorm. If we know the average waiting time of occurrence of an event, we can use exponential distribution. So let's set down a problem. The x represents the number of years after 2014 in which a snowstorm occurred. The x represents the number of years after the year 2014 in which a snowstorm occurred. Then x has an exponential distribution. Theta equal to a, because on average we wait 8 years. For occurrence of a snowstorm. Then next, write down a probability density function, not on a PDF. For exponential distribution, the PDF is 1 over theta e raised to negative x over theta if x is greater than or equal to 0, and 0 otherwise. Here, theta is a, so I plug in number a for each theta. Theta is a, so plug in number a for each theta. First question, what's the probability that there's a snowstorm this year? How do we set it up? What's the probability that there's a snowstorm this year? That's the year 2014, 2015, 2016, 2017, 2018, 2019, 2020, 2021, 2022, 2023, 2024. So the last snowstorm occurred in the year 2014. Assume our time starts from here. January 1st, 2015 is t equal to 0. January 1st, 2015, that's the time. That's t equal to 0. S equal to 0. We use x to represent time. S equal to 2, 3, 4, 5, 6. This year is 2020. We're looking for a probability that there's a snowstorm this year. So S equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. T equal to 5 is here. Here T equal to 6. S equal to 6. So January 2020, X is 5. On December 31st, 2020, X is 6. So take probability that S is between 5 and 6. Including 5, not including 6. Probability that S is between 5 and 6. Including 5, not including 6. So take integral. Here I forget support. Support is from support of x. Support for any exponential distribution is from 0 to infinity. For 5 and 6, 5 and 6 here is between 0 and infinity. So for 5 and 6, take integral from 5 to 6. 5 and 6, the integral 5 and 6 is in the support. So take integral from 5 to 6. F of x dx. And when s is between 5 and 6, s is greater than 0. So we use f of x equal to 1 over a times e raised to negative a over x. One over a e raised to negative x over a dx. Then take antiderivative. When we take antiderivative, 1 over theta becomes negative. E raised to negative x over a. Evaluate from 5 to 6. If I plug in 6 for x, I have negative x, negative e raised to negative 6 over a. If I plug in 5, I have negative e raised to negative 5 over a. Then simplify, I have e raised to negative 5 over a minus e raised to negative 6 over a. That's the probability that there's a snowstorm this year. That's the probability that there's a snowstorm this year. Part B. What's the probability that there won't be a snowstorm before the year 2024? What's the probability that there won't be a snowstorm before the year 2024? 2024 is here. Yes, there won't be a snowstorm before the year 2024. That means the snowstorm come after 2024. That means snowstorm come after 2024. There's no snowstorm here. That means snowstorm occurred. The snowstorm occurred after 2024. What's x here? 1, 2, 3, 4, 5, 6, 7, 8, 9. In January 1st, 2024, x is 9. We're looking for the probability snowstorm occurs after 2024. Means we're looking for probability that x, the waiting time, actual waiting time is more than 9. That means we're looking for probability that the actual waiting time for the occurrence of an event is more than 9. Suppose from 0 to infinity, if s is greater than 9, the integral from 9 to infinity, f of x dx. When s is between 9 and infinity, s is greater than 0. So we use f of x equal to 1 over a times e raised to negative x over a. Plug in. Integral from 9 to infinity (1 over a times e raised to negative x over a dx). Then take antiderivative. 1 over theta become negative sign. E raised to negative x over a. Evaluate from 9 to infinity. If we plug infinity, e raised to negative infinity is 0. E raised to negative infinity is 0. Minus negative e raised to negative 9 over a. And we know that double negative is positive, and so it's e raised to negative 9 over a. So the probability that there won't be another snowstorm before the year 2024 is e raised to negative 9 over a. Next example. In a restaurant, according to its past experience, customers arrive at an average rate of 10 customers per hour. Assume the restaurant opens at 11 a.m. In a particular day, what's the probability that there are no customers in the first 10 minutes? Part A, use Poisson distribution. Part B, use exponential distribution. So let's do part A first. Use Poisson distribution. So if I use Poisson distribution, let x represent the number of visiting customers. The x represent the number of visiting customers. In the first 10 minutes. The x represents the number of visiting customers in the first 10 minutes. Next, let's find theta. Theta is the average number of visiting customers in the first 10 minutes. Next, we need to find theta. Theta is the average number of visiting customers in the first 10 minutes. We know that customers visit at a rate of 10 customers per hour. 10 customers every 60 minutes. What we are looking for is number of customers in 10 minutes. Lambda represents average number of visiting customers in 10 minutes. Lambda represents average number of visiting customers in 10 minutes. So put the number of customers on the top, put the number of waiting time on the bottom. Then cross multiply, solve for lambda. 60 lambda equal to 100. Lambda equal to 10 over 6, which is 5 over 3. So on average, we expect 5 over 3 customers in 10 minutes, in the first 10 minutes. On average, we expect 5 over 3 customers in the first 10 minutes. Since we know lambda, the average number of visiting customers, we can use Poisson distribution. So x has Poisson distribution with lambda equal to 5 over 3. Then write down the formula. For Poisson distribution, the formula is the probability function is e raised to negative x, e raised to negative lambda. Lambda to the power of x over s factorial. And here lambda is 5 over 3, so we plug in 5 over 3. Negative e raised to 5 over 3 5 over 3 to the power of x over s factorial. That's the probability function for x. And the support of x. For Poisson distribution, support of x is from 0 to infinity, all integers from 0 to infinity. For Poisson distribution, support of x is all integers from 0 to infinity. That's support of x. Now, based on this, answer the question. What's the probability that there are no customers in the first 10 minutes? No customers means probability that s equals 0. X is number of visiting customers. If there are no customers, means s is 0. When s is 0, plug in 0 for x, we have negative e raised to 5 over 3. 5 over 3 to the power of 0 over 0 factorial. Then 0 factorial is 1. 5 over 3 to the power of 0 is also 1. And so it's negative e raised to negative 5 over 3. That's the probability that no customer in the first 10 minutes. That's the probability that no customer in the first 10 minutes. Now, part B. Answer the question using exponential distribution. Answer the question using exponential distribution. For exponential distribution, the x be the waiting time for the first customer. The x be the actual waiting time for the first customer. Next, let's find theta. Theta is the average waiting time for the customers. How do we find theta? We know that customer visits at a rate of 10 customers every 60 minutes every hour. We are looking for an average waiting time for one customer. We are looking for an average waiting time for one customer. We are looking for an average waiting time for one customer. Put the number of customers on the numerator. Put the number of waiting time from the waiting time on the denominator. Then solve the equation for theta. I have 10 theta equal to 60. That means theta equal to 6. That means on average, we wait 6 minutes for one customer. That means on average, we wait 6 minutes for one customer. That's the average waiting time for customers. Then, since we know the average waiting time for the occurrence of an event, we can use exponential distribution. Since we know the average waiting time for the occurrence of an event, we can use exponential distribution. Here, x is exponential distribution. With theta equal to 6. Next, let's write down the PDF, the probability density function. The PDF for exponential distribution is 1 over theta e raised to negative x over theta. If s is greater than or equal to 0, and 0 otherwise, then what we are looking for is that what's the probability that there are no customers in the first 10 minutes? What's the probability that there are no customers in the first 10 minutes? That means we wait more than 10 minutes for the first customers. That means we wait more than 10 minutes for the first customer. If there are no customers in the first 10 minutes, that means we wait more than 10 minutes for the first customer. Here, support of x is from 0 to infinity. We are looking for the probability that we wait more than 10 minutes for the first customer. We wait more than 10 minutes for the first customer. What's the probability that there are no customers in the first 10 minutes? That means we wait more than 10 minutes for the first customer. S is greater than 10. The waiting time is more than 10. We wait more than 10 minutes for the first customer. Then for continuous random variable, we take integral. Suppose from 0 to infinity. So if s is greater than 10, take integral from 10 to infinity. F of x dx. When s is from 10 to infinity, s is greater than 0. So we use f of x equal to 1 over theta. Here theta is 6. 1 over 6 times e raised to negative x over 6. Plug in here. 10 to the power of infinity, 1 over 6 times e raised to negative x over 6 dx. Then take an antiderivative. We have negative e raised to negative x over 6. Evaluate from 10 to infinity. If I plug in infinity, e raised to negative infinity is 0. E raised to negative infinity is 0. If I plug in infinity, e raised to negative infinity is 0. If I plug in 10, I get e raised to negative 10 over 6. If I simplify, double negative become positive. I get e raised to negative 5 over 3. That's the probability that no customers in the first 10 minutes. That's the probability that no customers in the first 10 minutes. We use Poisson distribution and exponential distribution, we get exactly the same answer. We use Poisson distribution and exponential distribution, we get exactly the same answer.